Okay. Hello, everybody. Welcome to the Points of Topology Introductory University course. My name is Shavik, and this is the 11th live session for this course. So there will be one session left upcoming Sunday. The same timings, 6 to 8. That will be the last session for this course. Okay. So before starting further, please let me know whether I'm audible and is the screen visible to you. Please let me know. Please let me know whether I'm audible and is the screen visible to you. There are two students joined. Can anyone confirm whether I'm okay? Thank you. And is the screen visible to you? Please confirm. Krishna. Okay, Krishna Suni, can you please confirm whether is the screen visible to you? Okay, okay. Thanks, Krishna, for your confirmation. Okay, so let's start. Okay, before studying further, please let me know if you have any question or doubt from previous sessions. So two students joined. So if you have any question or any doubts from previous sessions or previous assignments, because literally because this is almost the final class before the exams, and next week is the last class. So please let me know if you have any question or any doubt. I shall wait for a few minutes. If I don't hear from you, then I shall today solve some problems. So please let me know if you have any question or doubt from previous session or anything like that. Please let me know. Okay, thank you, Krishna, for the confirmation. Mustaq, do you have any doubt or any question from previous session? Please let me know. If I don't hear from you, then we shall move. We shall start today's class. Okay, so it seems there is no doubt from any from the students. So okay, so let's start today's session. Everything working fine or not? Okay. So today's session consists of three parts: compactness, connectedness, separation axioms problem. So first we shall go for some problems for compactness. Meantime, some of the problems you may think that this is very easy, but believe me or not, since I have a TA for this course for a long time, it turns out that students often do mistake in small easy things. So that's why this question PDF contains many of the obvious theorems or exercises. Okay, so let's start with the following exercise. Okay, so first example, first problem tells that prove that if x is in a compact space, then show that any infinite subset of x has a limit point in x. Okay, so please try to do it by yourself. So first, please try. If you are unable to do, then I shall provide you some hint. Okay, but please try by yourself first. Take your time. And one more thing, while presenting, possibly the messages don't appear often. So if you're in doubt, please unmute yourself and let me know the doubt. Okay. Now for the timing, please start the problem one. That is, you have to show that any compact space in finite subset always have a limit point. Okay. Please try to solve it by yourself first. Also, if we're unable, I mean, also in the meantime, if you realize that there are some problems from previous session or last session or some assignments, please don't hesitate to ask, okay? Because these sessions are meant for the students in order to clear the doubts, clear the concepts, okay? So please try to make use of this kind of sessions. Now, please try to solve it by yourself first. Also, if you have some idea in your mind, so please don't hesitate to tell. So there is no need to do hesitation because these are problem solving sessions. So please try to make maximum use of this. So please try for a few minutes. If you're unable to solve it yourself, I shall explain the hint. Okay. So in the meantime, let me check the next problem.
Good evening, sir.
Hi, good evening. So right now, so there is one problem we're trying to solve. That is the first problem, problem A. So in this question, you have to prove that if X is compact space, then any infinite subset of X has a limit point in X. Okay. So um, if you are familiar with this fact, then you may recall it, or else you may try to prove it by yourself. If you're unable, I mean, whatever is coming in your mind, you may try to explain, or otherwise, if you want me to solve it, please wait for a few moments. In that, then I will show you some hint. Okay. So for the time being, please try to solve problem A and B. And if you're done, please let me know. Anybody of you are able to solve it?
For the first part, we can just prove it by contradiction, and for the second one, the example can be R with usual topology.
Correct.
Mhm.
Correct. What about others? Okay, so let me. So the first problem solved by method of contradiction, and second problem, whatever she explained, is the correct example for this problem number two. So although I put the argument of problem A, but if you want, then only you can look into it, or else we may skip it. For the time being, I'm skipping this because one of the student already solved it. So let's not waste more time for this problem. So let's go to the next problem. So what about other two students? Are you able to get it? If not, in that case, please look at the solution, because this particular problem is very easy. It's true, but in last semester, I mean in last year, this course, many of students um, wrongly solved this problem. So that's why we can't ignore any problems, given the fact that it may seem easy. So basically, what we are doing this problem? Basically, we're so is the infinite set, okay, and we are assuming that it has no date point. That means what? That means if we take any x belongs to x, and since x is not a limit point, so we can find an open neighbor ux of x, so that ux intersection a, which is sum of singleton x, right? That means what? Now consider the collection of ux. It's an open cover of x. So by compactness, this collection ux has a finite subcover called ux1, ux2, dot uxn. Now, if you take A to be the intersection of A intersection EY, union of A intersection EY, this collection form a cover of M, but A intersection EY is singleton X. So that means what? That means A is equal to, that means A is equal to X1, X2, Xn finite set. So that's what the contradiction is. Okay. So yeah, that's the argument. So the next second example, what she gave is absolutely correct. So there is nothing more to explain. So let's move on to the next problem. So the next problem tells that the extreme value theorem. So if f(x) towards continuous x is compact, then it show that f attains its maximum and f attains its minimum. That means we can find we can find x not x1 such that f of x not is equal to supreme of fx and f of x1 is supreme of fx. So yeah, and also you give an example to show that unit or unit circle is not homomorphic to R. Okay, so that's what I need to show. please try to do it by yourself. So in some textbook, this first problem uh, is given usually as an theorem, but it's a textbook, it's an exercise. So in any way, please try to solve it. So the hint are as follows, because without hint it is difficult to solve. And also in exam also this problem is given, then of course hint will be given. Okay. Anyway, that's not the point. So the hint is given, please use the hint and try to solve it by yourself. And if anybody done, then please let me know. Please take your time. Anybody able to solve it? Anybody able to solve it? Please let me know. Sorry, due to technical issue, to just reshare it. Just hold a moment. Let me reshare the PDF. Okay. So, okay, so anybody will do solve it, please let me know. I mean, if you just use the hand, it will be get solved immediately. Sorry. So please let me know. So see I mean, okay, it's more than 5 minutes for this problem. Okay, so for the first problem, so since it's a continuous map f from x to r, so in that case, image f of x is a compact subset of r, right? And continuous image compact set is compact. So that means what? That means f of x that is compact subset of r. Now by Heine-Borel theorem, compact subset of R nothing but closed or bounded. That is of the form closed interval a comma b. And we need, so that means what? That particular closed interval a comma b that contains infimum and of course contains supremum, right? So that's the argument. So there is nothing more what to do. And second problem is that prove show that unit circle is not homeomorphic to what? To a real line. And it is definitely true. Why? Because the real line is not compact being not and also the S1 is compact. So that's the thing. Okay. So the detailed solution is as follows. A moment. The detailed solution is as follows. So first of all, if x2r is compact, x2 is continuous, and x is compact. Okay. What happened to the PDF? It is not working. The first one. Okay. So sorry for the interruption. There is some internet issue. Anyway, so now since x is compact and if it's continuous, so the image of fx is compact. Okay. So by Heine-Borel theorem, so Heine-Borel theorem, f of x is closed and bounded. Okay. And if of x is bounded, that means what? We'll get a supremum as well as infimum. Now, bounded and compactness implies closeness. That means what? Supremum and infimum both belongs to that set itself. Okay. That means capital M and small m both belongs to f of x. Correct? That means what? We'll get a, because that means what? Little m and big M lies between the image of f. That means what? We shall always find a x naught belongs to x as that f of x naught is equal to capital M is equal to sub fx. And f of x1 is equal to small m is equal to infimum of x. Okay. That's what it is. Okay. So this tells that a supremum and infimum both belongs to the image of f. And the next thing tells that S1 is not homeomorphic to R. I mean, it is obviously true. In many ways, this can be solved. So here is one possible way. There is a homeomorphism. So this particular theorem tells that if so here it is saying that R is not compact if it's compact. I mean, here we're using compact means we are proving this. However, using connector also it can be proved. For example, consider S1 and R. Okay. Now S1 minus a point is still connected, but R minus point is disconnected. That means what? That means S1 and R, these are not homeomorphic. Okay. So that's what the argument is. So are these two arguments clear for this problem? Please let me know. Are these two arguments clear for this? Please let me know. Okay, I hope these arguments are clear for you. So let's go to the next problem. The next problem tells that suppose that the house between Q1 to disjoint compact subspace. Prove that there is a disjoint open the U and V so that Q1 sub of U and K2 sub of V. Okay. So please try to do it, prove it by yourself first. Take your time. Pretty able to solve it. This problem is easy. We have explained this problem in the class. So this particular problem tells what? This particular problem tells that the Hausdorff, compact Hausdorff space are normal. So this thing we have proved, I guess. But still, anybody, if please try to do yourself. And anybody, you can unmute yourself. Let me know. So anybody, any guess or any idea? Okay. So please. Okay, so the hint are as follows. Please so just 2 minutes. So hindered as follows. Okay. So we've already proved that for any, if we take any point x outside a compact set, we can find a disjoint open set separating x from k, right? And now if we do this every point of k1 entire against every entire the full set k2, then we'll get uniform superposition. So that's the argument. That means what? For each point of k1, we can get an open set containing which point? Containing the set k2. For each of these points, we are going the open set, and by compactness, those open sets are finite. Then we will take the intersection of those open sets that contains k2. And that means those u and we then we will get the union u and v such that this property holds. Okay, that's the argument. So now the solution is as follows. So K1, K2 are disjoint compact subset of Hausdorff F2. Sorry. This and we separate each point K1 from K2. So this is the separation. Please go through it. Then I shall go to step 2. Now, now since for each point x of K1 we can get an open set containing that point and an open set containing the set K2. So those ux that collection of ux's forms an open cover of the set K1. Okay, now K1 is compact. So that collection is find the collection of the finite sub collection containing all this. So the so I mean so since by compact we shall get a finite sub collection, that means we get a point x1 x2 xn, that is k1 sub of u x1 dot u of xn. Okay. Now we define u is equal to u x1 union u xn and v is equal to v x1 intersection v of xn. Now v is open, u is open, so k2 sub of v. And disjointness, if y belongs to u intersection and again y belongs to u xj for some j, that tells that u intersection be empty with k1 sub of u, k2 subset of v. Okay. There is one student whose mic is please unmute, please mute yourself. Okay. So okay. Now, since define u is equal to u of x or u x xn, in that case, I mean, in that case, that set u contains capital, like when v contains the capital K2, and by our choice, u intersection v is equal to empty. So that is the full argument. Okay. So there is nothing more to explain. Now the next question. So this question, suppose f is a map x to continuous, so x is compact, y is Hausdorff. You need to show that f is homeomorphic. It's a very popular question. So please try by yourself and try to solve it. So in this question, basically what you need to show that F is a, I mean, of course, F is a homogeneous, there is nothing to show. I mean, basically we need to show that F is a closed map, okay, because it's a bijection, so bijection is already there. So that either openness or closed you need to show, but of course you need to show here that F is a closed map. And that means what? That means you need to choose a closed set from the domain and to show its image is closed in the codomain, okay? So that's the process you need to solve. So please take your time, think about it, and let me know. Okay.
Can we do it by taking a closed set in X, like say a subset of X to be closed, apply continuity over there, saying f of c is compact in Y, then use Hausdorff property because compact sets are closed, f of c is closed in Y, and finally say f maps closed sets to closed sets because f is bijective, continuous, and closed, so inverse is continuous.
Well, finally, what I'm concluding? I mean, how are you concluding? Okay, so after concluding F maps closed to closed set, what are you concluding?
Because f is bijective, continuous and closed, its inverse is continuous, therefore f is a homeomorphism.
Very good, very good. So the explanation she gave is absolutely correct. So that is, so let's not uh, wait more time for others to respond. So the argument is basically, let me explain once again. So choose and close set C is from the domain. One minute, hold on. Yeah. So from the domain side, choose a closed set. Okay. Now f is continuous. So its image called C. So f of c is close. F of c is compact in Y. Now Y is Hausdorff and compact also Hausdorff space is closed. So f of c is closed. So that means c closed implies f of c closed. That means what? That means f is a closed map. So that implies that f is a homeomorphism. Okay. So that is the argument. Now let's go to the connectedness problem. So first problem is as follows. Prove, sorry. So first problem, prove that if A is a subset of orders connected if and only if it is an interval. That is, for any point A and B, if A less than B, with every C with A less than C less than B, satisfies C belongs to. That's what an interval is. Okay. So please try to show that A is an interval if and only it's connected. Narayan, or do you want to say something? Narayana, or do you want to say something? If not, then you please mute yourself. Okay, for the time being, please try to solve this problem. That means what? First, assume A is connected. So, first assume that A is connected, then show that A is an interval. Okay, so please try to do it by yourself. That means what? You need to assume that A is not interval. That means you will get a C such that A less than B, A less than C less than B, but C is outside A. And in that case, you need to show what? You need to show that A is not connected. So yeah, so please try to solve it by yourself first. Please take your time. Please try to do it by yourself. Narayana, or do you want to say something? So if anybody done, please let me know, or in shortly, please explain the argument. Okay, so any idea how to solve this problem? I mean, it's of course very easy. Just you can unmute. So let me know the argument. Okay, so let me. So Narendra, do you want to say something? Oh, very good, Narendra. Okay, okay, so okay, so the solution can be done with method of contradiction. So suppose there is an interval but disconnect. That means what? So that is that we can write A is equal to A union B. Now that no sooner we can write A is equal to A union B. So by least round property, it is possible to find an inter point C and D which belongs to A but doesn't belongs to C, but doesn't belongs to the E union B. And for the forward direction, the method is contrapositive. We're assuming the fact that A is not convex. From that we shall basically exhibit a disconnection of A. Okay, so that's the argument. So the detailed argument is as follows. Suppose A is not an interval. Then we can find an AB with A less than B and C belongs to A comma B. Now define U is equal to A intersection minus inverse V is equal to A intersection C in C comma A. Both are open with the sources to topology. Okay. Now since A belongs to now since A now since we have A is equal to union V, every point of A is either. So in that case, U not equal to empty. Since A belongs to U, V not equal to empty since B belongs to V. So U intersection V must be empty. So that is the argument. Okay. For the converse direction, suppose there is an interval. And for the contradiction, we are assuming there is a union V separation, even non-empty disjoint. Okay. So we are choosing A belongs to A, B belongs to B. Without loss of generality, we can assume that A less than B. Since A is an interval, AB is subset of B. So choose A is equal to supreme of U intersection A comma B. And and U intersection A comma B is equal to empty. So that is the supreme of A exists and A less than S less than equal to B. So S belongs to closed interval A comma B sub of C. Okay. So that means what? S belongs to V, and since V is open, there is epsilon with we can find epsilon with uh, S minus epsilon comma S plus epsilon intersection S sub of B. Then U intersection S minus epsilon comma S is empty. That tells that S equals supreme of U intersection A comma B. So that is the argument. And suppose this belongs to U, in that case S is open. And our same argument tells that S equal to U intersection A comma B. So in that case, we will get a contradiction of both sides. Okay? So that is the argument. So please go through the argument once again and let me know if you have any doubt. Please go through the argument again once again and let me know if you have any doubt. Okay, thank you for the confirmation. Okay, so let me. Narayan, do you have any doubt, or else you should mute yourself.
Hello, sir. Sir, actually, I have a doubt regarding this problem.
Yes, yes, yes.
Sir, actually, I missed a lot of lectures, like because my quiz are going on, so I missed the lectures. Now I'm trying to covering the lectures, but it looks like impossible, and the exam is coming soon. So I want to ask, like, what should I
So,
prepare for exam?
tell me one thing that, yeah, so are you looking for writing the exams of the NPTEL final exam, right?
What's sir?
Are you willing to write the NPTEL final exam?
Yeah, yeah, I filled the exam. Yes, sir.
So, in that case, so does the instructor, I mean, Professor Sastry, share the lecture notes?
Yeah, I have the lecture notes. I'm trying to understand by the lecture notes, but from then I'm thinking like that I have to attend the lectures, and the lectures are like very attentive. Like if my
See, the
like
point
if
is
I
that,
move,
I mean,
yeah.
okay, I mean, you can go through the lecture, but it's better
Actually,
to
sir,
go
the
through the
main
lecture
thing is
notes.
like currently I am in IITM and pursuing second semester. So there I have already a course points at topology. So basically, my interest was in topology, so that's why I joined that NPTEL course. But the like pressure was so much on the quizzes going on continuously, so I missed lectures, and now it's like a very I don't know how to handle this, and I want to write the exam.
So, I mean, okay, so so since you have already a course upon topology in the
Yeah,
masters currently, so
yeah.
what's the benefit of writing the NPTEL exam?
Yeah, actually, I just want something about in my resume in CV to add a certificate I will get.
Okay.
So that's why. And the topics sir are teaching like Lindelof and all those topics, separability. And in my course, like currently, my sir didn't teach this. I don't know, like the course
So
structure is very
who is taking the course?
that Suhas J Pandit sir.
Okay. So currently, what he is doing? I mean, which direction he
Currently,
is teaching?
he is doing like that SAPes structure. He is doing like the first one about was done, but now it's like I forget. Uh, that deformation is something like he doing.
No, 1 minute. So yeah, so isn't it that course is on points of topology? Am I not right?
No, the courses points at topology only, sir. Because in first semester I had real analysis. So after that, that points at topology introduced.
But in the points of topology course, he is doing deformation, retract, all those things. Is
Yeah,
it?
homeomorphism, equivalent, how to show these are, and then but the since these lectures he introduced that local connectedness, path connectedness. These
Hmm.
topics are introduced, but after that again he came back to that topic like deformation, continuity, these all things. So I just want some suggestion because now I'm like dead. I don't know how to.
And tell me one thing. So the second quiz is over, right?
Yeah, now I have time. Like I have 1 month time because ENSOM is on 6 May,
Okay, okay.
and the exam is like on 20 May, 20 April maybe. I forget the date. 24 or maybe I think.
Okay, so this is so that so the NPTEL exam, is it?
Yeah, NPTEL exam.
And when
And
is
I
this
want to ask
institute
like
exam?
how the exam questions are from where like.
See, what? See,
Oh.
I
Like any some idea or do you have to like
so
I don't know what to do. That's why I want to ask like
so I mean the questions are actually not very difficult if you know the basic definitions. I'm the TA for
okay.
this course for last 3 years. So the point
Okay.
is, if you know the basic definitions, if you have the basic understanding, 60 to, I mean, at least 70% problem you can solve.
Okay.
There are one tricky problem, few tricky problem that is okay, but 70 to 80% problem you can solve by yourself if you know the definitions. Okay.
Uh, I-
I mean,
okay. It's
definitions
based
of
on
all those
concept.
things which are in the syllabus. So if you know all
It's
this, then
it's
you
based
can
on
get.
concept, sir.
Yeah, it is based
It
on
doesn't
concept,
come
but
from
it is
the.
not, that much difficulty.
Okay.
That's what it is. I mean, it is not really very difficult. Of course, you have to solve at least some problems. Without this, it's not possible. But the problem is that since I also attend this Suhas Sir's class, so I know the
Okay.
problem. I understand the problem.
Yeah,
Now,
yeah, yeah.
since the
That's
situation
the
is
problem.
that
Like he just don't care about the exam. He will just teach.
no, that is not the problem. The problem is that the problem is that in the final exam, whatever he taught in the class, that will be given in the exam, right?
Yeah, it will
So,
given.
so that thing cannot be ignored. So that is the problem actually.
So that's why, I want to ask some suggestion how to,
And
because I completed the like today I completed the eighth week lectures, but now I have to complete ninth week, 10th and 11th week, and 12th week is currently going on from the Monday tomorrow.
okay, so I have one question that I mean, what I mean, why you go to the lecture videos instead of going through that lecture notes?
Because I think that some concepts are not there in the notes. So what sir is teaching, that's why I joined the course to understand the way of he is telling the concept. Yeah,
Uh, mm,
I'm also studying from
but
notes, but
but the
okay,
point is that I mean, you should follow the notes because while creating questions, he follows the notes extensively.
okay.
So whatever the note exists, please
And the main
follow it
problem is
blindly.
like Anand sir give a lot of exercises.
Okay. Exercise means assignment, that you saying?
It's like I'm completing the lecture, but at the last there are a lot of exercises. So I want to move to the next lecture, but I can't move. So firstly, I have to solve all those exercises. It will take again a 1 hour. So like lecture complete is like a very big task. And I want to complete the lecture, but I can't because currently from tomorrow again I have classes schedule, 6 classes. All the 6 courses are there.
Correct, I understand.
Any solution is there? That's what I'm asking.
Solution. So just tell me one thing. In the
Yeah,
NPTEL certificate, is the marks mentioned or just it will be written like passed or failed?
it's just like I think the certificate is just like that. I don't think they will mention the marks.
And how many marks do you have in assignment? Any idea?
I don't know. I didn't add the assignment marks.
The point is that since
And between the
only target
yeah,
is to get the assignment, so to be
okay,
honest, you no need to take too much of pressure. If you know the
okay,
definitions, you can get
yeah,
easily passed. Okay. Because
okay,
while checking answer script, already from the NPTEL side team, it has been communicated many times to make
okay,
sure that if most of the students should get passed. Okay. So unless and until you don't write anything, that is the problem. But otherwise, if you know that basics definitions, at least
yeah,
suppose some problem is given in the
okay,
exam, but suppose you are unable to solve it properly, but you know the
okay,
definition, you wrote the definitions, then you can get partial marks. Okay. So
okay.
the getting certificate is not it is difficult. The point is knowing the definitions and how to use
Okay.
the definition to some small problems. That is very important. Okay.
It's just of MCQ or MSQ type, right, sir?
Most of the questions are so there are MCQ questions, fill in the blanks kind of questions,
Oh
MSQ
my
questions,
God.
and yeah, there are filling the blanks questions. So that's why you need to know the definition and small theorems or facts and few large questions. I mean, 10 marks questions, but that
Okay.
those are
So
not
he
actually
can
that
give proof
difficult.
also. He can give proof also, right, sir? There is a possibility.
Of course. I mean, in big questions you have to do proof also.
Okay. Sir, do you have any idea like last year exam? How is it looks like? Can you share the exam?
Okay, I will share. In that case,
Yeah, like then we can get some idea and like okay, these type of questions, idea some.
hold out,
Okay, sir.
hold out. Okay, I had the question in mail. I have the question in mailbox, but right now I'm unable to recall the subject line for that particular question. Okay, so you can drop an email. I will
Mhm.
share it. Okay.
Okay, sir.
Yeah. I mean, anyway, no need to take too much pressure because anyway you will get certificate. That will not be very difficult actually.
Yeah, it's like I
You
joined
need to
that.
make sure you have good marks in this
Yeah,
semester exam.
that's what.
That's more important.
And rather than that, I have a extra course. Like I also took that real analysis in NPTL only, and also exam registration for this also. And so for that course, I also missed the lectures again. So total,
Reanalysis
I think
reanalysis by who?
that Inder Kirana, I'm
Okay,
joining.
okay. There's a recorded course, right? That one.
Yeah, yeah. So basically, I just want to make my like core concept, like basic concept in topology too strong. That's why I can move forward in PhD or
It,
something too.
it's a topology one, right?
Yeah,
So see, the point is very simple. Whatever the, I mean, if you go to higher directions,
yeah,
so most of the material in topology two are not going to be used in later on.
yeah, yeah.
So you may safely ignore this. That is this
Because
problem.
it's like topology is just like spacious in algebraic topology is the main. In point set topology, we are just introduced by terms only
Correct.
to get like they are same or not.
Correct, correct,
But
correct.
it's also important for marks. We have to get marks.
Yeah, right, correct. So
Yeah,
whatever the was said is teaching, I mean, you have to ensure a good mark, otherwise getting PhD admission, it's very difficult.
yeah, yeah,
Is also apart from this, it is very difficult to get inspired in BHMs. I mean, of course, for NBH you have to write the exam for that basic
yeah,
concept has to be cleared.
yeah.
And for Inspired also, you need to have very good marks for applying the application itself.
Yes, sir.
Okay.
So that's the problem, like getting a lot of pressure. So that's why I didn't join meeting also, sir. Like meeting online meetings are going on. So today
So
I join and I think
as,
I will get some suggestions from you.
as long as you are able to solve problems by yourself,
Yeah.
that is the ultimate target, right?
From like if the problem is given, like firstly I will apply the definition and just some argument. Like maybe the possibility is like I can solve, but not confident. Like there will be some problem.
So I mean, what the problem are you facing? Please repeat.
Which problem, sir?
I mean, you are not getting confidence, something like you said, right?
See, we have given like we have to prove like it's locally connected and connected, then it will become path connected. Uh,
Okay.
if a set is like locally connected and there is a
Mhm,
property of connectedness,
mhm.
then we can say that that set will become path connected. So the idea is like we can construct a subset of that by joining, like we are fixing a point and collecting all those points which are joined by that point. So
Correct.
now we have to show that it is non-empty and it's closed and open also. So by that property, it will like only clopen sets are only connect like empty set and full set. So that means that subset becomes a set. So that means for any 2 points we can join them by a path. So like that's the idea. So we have to write. So like I am saying it, but I can't write clearly. Like I miss some point, and that will goes in the wrong direction. Some
Hmm.
writing problem is there.
Yes, for that you need to practice. I mean, there is no other way
Yeah, the
it can be
practice is
fixed.
needed.
Genuine problem. I
And
accept
the
that.
problem is like that supremum, infimum, this question, like if I'm approaching with the like contradiction, then the proof is given by like the simple proof. If I'm approaching by simple approach, then it's like a contract. Like it's
Correct.
never matched with the proof. Like
As of
concept, like we are like let's given we have a problem and we have to prove. So there are a lot of approaches to prove this.
correct.
Yeah. So maybe if I'm approaching by another approach and I'm applying
So
the
that's
concept.
no, that's why you have to lot of practice. Without not only this subject, any subject requires practice, right? Without practice, it will be difficult to do anything.
I think in other subject we have to just something, at least we have something in our hand, like we are applying formulas or something. But in this subject, particular subject, we have to just get better with the concepts.
Yeah.
Uh, wo-
Also,
yeah,
which book are you following?
that there is a general topology book, KD Joshi and the S Kumarasan, and the Dugand Joshi book. I don't prefer so much, and the Atkinson book. Sorry, not Atkinson. That Armstrong, Neela, that Armstrong book.
Okay. Okay. So I mean, yeah, these books are quite difficult also. I mean, okay.
That's
So
why, sir, in the first meeting, I asked you, like, is there any easy book to prefer to understand the map?
are you following Mancres?
Munkars, I sometime opens.
In topology, there are, I mean, in topology, it is difficult actually without practicing. It is not possible. I mean, you can't expect that one time you go the definition and after that you can able to solve many problems. That is not the way. I mean, it will take time actually. That's why you have to practice. Otherwise, it's not possible.
Yeah,
And
yeah,
whatever you say first as doing, it is more than difficult than that. So you have to do a serious amount of practice.
yeah.
And the problem is that in topology, you simply can't guess this will work or not because there is so much abstractness, right? So that's why in order to have a correct approach of the proof, you have to do a lot of practice for exams. Otherwise, it's very difficult. Okay.
Yeah, okay,
And
sir. That,
I don't, and
okay.
I don't know how this Atkinson book, I mean, how this book Atkinson is.
Not Atkinson, Neil, that Armstrong.
Okay, how that is, how that book is.
It's just like the book is very good. It's like showing the pictures to understand that algebraic topology parts, like that clean border identification to make like gluing that one point. That's like for that things. It's very good that Armstrong book. Munkers is also good, and in Kumarison book, it's like a concept related, like compactness, basic definition. And that Joshi book is like introduction to general topology. It's good only. It's like it's just written there like a pure. I don't know. This book is difficult little bit.
Okay, so in that case, you may try to solve the problems from one quiz also, because
Yeah.
the problem because the problems of one quiz are actually good in nature, and the one problem involves many small concepts. So that's why you should try to solve the one quiz also if possible.
Yeah,
Okay.
yeah. Yeah, I will try. But that's the thing, na sir. It's wants time. It just want time.
And I understand. I understand that.
And
If
something like in the quiz one, around quiz one, I put much more time on that topology. So from other subject, I did bad. Like not bad, it's good only. But that's why this time I maintained like with all of the subject, because if I focus on one subject, then my CGPA will be
yes, yes,
gone.
yes, that's a problem. So,
That
Suhas is following absolute marks or relative mark?
Suhas sir is following that Munker's book and that Armstrong book.
No, no, I'm asking about I mean marking scheme. Is he following absolute marking or relative marking?
No, he is giving partial. Like he will give step marks also.
Okay,
He marks very good, but the first exam, quiz one exam, is like very bad for all of like the C average is very bad. It's around 4 or 5 out of
and
15.
after final exam, which scheme he will follow? Absolute marking scheme or relative marking scheme?
I don't think it will like not strict like it's just a normal like. He didn't say about anything. Like he didn't discuss anything about the exam purpose. He just come and like teach and he leave.
Mm.
Did you work under like Suhas sir also?
I want. I have. I have one course under him. So
Okay.
in my PhD, that's why I know the nature of that
So
course.
you did PhD from where? Like
No, I'm doing PhD from IT Matters
you
itself.
from where, sir? Bombay.
From IT Matters, this institute itself.
You are doing PhD from here.
From IT Matters, yes, yes, yes.
Oh, so which year it's your?
So I'm in now fourth year.
So you are currently in IITM.
Yes, yes.
So which department? Like in mathematics?
Come on,
I didn't.
mathematics department, of
So
course.
you are not under Suhas sir, right,
No, no,
sir?
I'm not under SWAS. I'm under Ramesh sir.
Which? Oh,
Ramesh,
that
Ramesh.
Ramesh Kamalingam,
Asilingam.
Kasilingam. Oh, I met them there. He's good only. I talked to like when the we had to choose elective papers, sir. So that day he came to our class and he introduced about that topic, like join. That's why I'm going to join in the next semester these courses, that algebraic topology and differential topology. So
Great.
he told like come and it's good.
It is good. Okay. I mean, it is good. I'm not saying it is bad. But after PhD, what's it? Then that's the question.
uh, how's your like PhD is going, sir, under him?
Um, so it is going good actually. Um,
Okay.
um, I mean, the answer is quite complicated. It is not a one-line answer. It's a very subjective matter. It is a matter of discussion. It's not. I mean, there
Like,
is nothing like it's good or bad
what about
because
like marking? Did he give marks or not? I'm not asking about like I have to also think about that CGP also.
for our batch he gave for our batch he took advanced algebra topology. Okay, and there are
Okay.
only three students who took the course. So obviously he followed
Okay.
the relative marking.
Okay.
Now, for MSc, there
Relative
are many
marking, I think
schools.
here also,
Yeah,
like,
negative. Yeah, relative marking is actually good, but provided one student shouldn't get extreme high, another student shouldn't get extreme less. That's
yeah,
then
yeah,
the
that's
problem
the
comes.
problem.
Because
And
at
the
least you have to make sure A grade at least. You couldn't
yeah,
go below A grade, right?
and the main problem is like these people, like the relative grading happen, and like the BTech peoples are also there, and they obviously like they get always like not always like they always get good marks. So from them, our CGPA get down.
Hmm.
It's like it's a relative grading with like MTech people also, BTech people also.
This so this problem has to be discussed with the class representative to us to
They
sir.
can't even do anything, but I think it's like BTech students come in our class, so I think it will be a relative grading. I think we talked to our CR also, and they told like it can't we can't do anything.
No, the point is everything is in professor's hand. Okay, so if many requests come, then it will work out.
Yeah, maybe then he can then they will think about that.
Yeah,
So then
yes.
you are in IIT Madras, then you know how the hectic is. You can know the like
Yeah,
they
yeah.
are in six courses are going on, and like when our quiz are going on, then still we have classes. So
Yes,
like I
yes,
miss
yes.
that concept also. Then when after quiz I have to collect all those concepts, I have to study those concepts. Then again new concepts are going on. Like it's so much pressure in IITM.
Not only here in MSc in good institutes there are pressures and it is not deniable
But I
fact.
don't think, sir. My one of my friend is in IIT Kharagpur,
Hmm.
and like there is comparability. Like there is no pressure in like how we have process. There are no pressure in like on her. Uh, uh,
So is it like in IIT Kharagpur there is no pressure on attendance?
no, I think attendance is like fine.
No, attendance fine means, for example, here you need to attend the class. That is
No, I
mandatory.
don't think so. Here in just particular some classes, like in one of the courses is combinatorics. So there is particular like attendance is mandatory. But in other courses, like they don't take some like they don't take attendance. Like in Ponnuswamy sir, they don't take attendance.
That is better.
Yeah, so like attendance is not mandatory except some courses.
And in IIT Kharagpur, one semester is around how many
5
months?
courses.
One semester in IIT Kharagpur in how many months?
How many months? It's like 4 or 5, 4 and 5, 4.5, 4.5 months. It started in January and it's going to end in 15 May around.
So there is time is
No,
little
not
bit.
yeah.
So here time is actually very less. That is the problem. And more code two.
And here in IITM, like it, they will complete the whole semester in less than 4 months. Like it's
That is a
started from 19
hmm.
January and it's finishing going to finish on 13 May. It doesn't even 4 months.
Yeah, yeah, it's correct.
Like they are giving so much less time, so much vacation. Like we don't want any like.
No, no, actually it's the engineering institute, right? So the engineering people
Mm.
has many internships started. So that's why the vacation is necessary.
Yeah, it's
So
like two
that is
months vacation we have.
yeah. So that's why there are so much vacations for the internships thing.
Yeah,
Otherwise, it will be very difficult for them because I mean they are the primary stakeholders of this IITs, right?
yeah.
So that's the situation is. So what drives you to come to the direction of PhD?
I don't know. Like from
No, no, it is not
firstly,
that
I
you
got
don't know. I mean, you have
no, no.
to
I
study,
know.
right?
Like firstly, if I tell the concept of PhD, then it's came from like 10th or 11th, 12th. Like I want to go in PhD without knowing what PhD means. But when I came here, so I'm not interested in like that field, that Python, AI, machine learning. I'm not interested in these parts. So when I'm studying that real analysis, firstly, I got interested in these subject when I study that real analysis. And why Matra sir? He teaches very well. Like it's very good. So from that, like real analysis, then after that, the topology part came. So like getting motivated to do PhD in topology only.
So that means you are, I mean, that means at least till now, you want to do PhD in pure mathematics. Am I right?
Yeah, in pure mathematics, no applied or something. there may be a possibility like measure is also good, but it's so abstract. Like sometimes, like if you are not, if you are not like, firstly you have to be calm. You have to be like calm. Then you can think. You can think. You can each add each concept. Then you get answer. That's the thing. And measure is good subject, but it's fine only.
Point is, topology also it is extremely abstract at the
Yeah,
higher level. You
it's
simply can't.
extreme abstract. Yeah,
You
but it's like topology. I can. It's
till
like
now,
as a,
till
yeah,
now in the deformation retract, in the fundamental group, all those things you can at least visualize. But after
yeah.
that, nothing can be visualized. So it
Okay,
is same. The same thing is measure theory. The same in higher topology. The same is algebra geometry. Those things cannot be visualized at the higher level.
okay. Give me some idea. Like topology is good or not for PhD. Like what's the future? Like what's the scope of this
So to
course?
be honest, the scope is very difficult. I mean,
Yes.
unless and until the student is a prodigy kind of, it is very difficult to get a job.
Okay.
Now you must that there are so many institutes, so many students. The point is that it turns out that after having even postdoc, people have to land into private university. So now in private university, no sooner you enter a private university, you don't have really time to do research because of course there is no benefit for any direction.
Yeah.
So in that case, either you have to change the subject or you have to again do research in order to go to some good government university. Okay, that is one thing. And secondly is that since you are only interested pure mathematics, so um, I mean that subject has no direct real applicability till date. Okay.
Yeah.
For example, if you want to go topological data analysis, that subject has an upcoming applicability. There is a big possibility, but directly only PhD in topology has no application in any fields or subjects or any other direction. It has no applicability. So not only this is the problem with this topology, in other pure science also the same kind of problem exists. So that is the real problem. I mean, it is not just having a PhD. After PhD, if you're not getting job, then it's just waste of time, right?
Yeah.
So but for sake of having knowledge, if you want to learn, that is another thing. But if you want to
Yeah.
ask me that for getting opportunity, it is very difficult to have opportunity after PhD in theoretical science, and it's a real problem. Unless and until you publish very good paper or you are a prodigy, it is very difficult to get a job, and it's a genuine problem. I mean, we cannot escape it.
Uh,
And it is
okay.
not that it problem will go end. It is the problem is increasing day by day
Yeah. Yeah.
because number of students are increasing, but universities seats are not increasing.
Hmm.
Also, if you look at the different institutes, like recruitment notification, they clearly mention they can take anybody without they can take any student or any candidate to their for their job as professor who might not have even the field of the form. So there is a problem of partiality also. Okay. So that means what you need to build a very good network. You have to go to some guy who has very good network to keep a job. Okay. Okay. So these are the actual problems in this pure mathematics. Not only pure math, pure science, the same problem because of this kind of less applicability. So that is the problem.
Okay.
I'm not saying it is bad or good. This is the problem. Now you
I just
decide
want.
what to do.
I just want facts also. Like, is it
I mean,
really
these are the facts. I mean, nobody can deny it. If you
okay?
choose any of the students
Mm,
from pure mathematics,
okay.
and there is a big possibility that that particular student is unable to get a job or unable to get a postdoc by himself or herself unless and until guide directly or indirectly help him or her. So these are the problems. And also getting a job is matter of big luck and big challenge. And also if guide has hand on you, then it is possible to get a job easily. Otherwise, it is also very difficult. So these are the real problems. I mean, and also it
And
has nothing to do with good PhD or bad PhD. PhD is a PhD because in PhD, for example, in your MSc marks, some
yeah,
MSc certificate, a marks will be given or a class will be given, right? In
yeah,
PhD, there is nothing like 60%. It's a PhD, it's a degree. You got the degree, that's all. After that,
Okay.
there is nothing extra to get judged.
Okay.
So problems.
And like, what if we say like PhD from foreign?
Okay, so PhD from foreign, suppose there are many institutes. One,
Yeah.
so currently, so there are many foreign institutes. For example, King's College London, King's College London. Okay, so in that institute, because one of my friend is doing PhD there, so I know there's this problem here there. So it turns out that they don't. I mean, so, while I mean, so in the problem is that in many foreign universities, so
Yeah.
while filling out the form, they don't even possibly tell you that you have to do a master's again from them. So they don't tell you usually. After getting selection, all of this, they suddenly tell you with via some mail that due to some
Okay.
policy reason, you have to do PhD, again masters from them. Then you can continue to PhD there. Okay, that is one
Okay.
problem. And secondly, in foreign, if you do PhD from that case, you need to make sure that your guide has very good network so that after coming back to India, you can get postdoc or job easily. Okay.
So like the
And
my aim is like to either do PhD from abroad, otherwise don't do PhD. It's like I will try again and again to do PhD, apply from foreign because I want to do PhD from abroad only, not from here.
okay, so yeah, okay. So in that case, you so in algebra topology, for topology point of view, you should try to go with China or Japan. Okay.
And what
So
about the Germany?
German is good, but currently, not only currently, for a long time, the Chinese people and Japanese people, they producing very good papers actually.
Okay.
So that is why, I mean, also, I mean, of course, you know personally somebody in Germany doing who is willing to take PhD student, you can go. But I'm telling you a general perspective. In China or Japan, the most of the faculties, I mean, in many universities, you will get algebra topologist and geometry topologist. So that is the situation. Now from mm, yeah, that's the situation. Yeah, China and Japan are very good options actually. But of course, for that you have to start. So currently you are in second semester, right? Second semester, right? You are in second semester, am I right? Okay, there is some internet issue, is it? Okay, it seems. Okay, she got disconnected. Okay, so okay, so the next problem is as follows. Just hold on, please. What happened? This again. Mm, Okay, so the next problem is as follows. Okay. So the next problem is saying that suppose A alpha is the family of connected subspace. So the intersection alpha is non-empty. They want to show that union A alpha is connected. Okay. So this problem you can solve it by two ways. Either that you can solve this problem in two ways. Either union of A alpha is connected Okay, so this one has to do either you show the function, that is choose the function f from union of p alpha to plus minus 1, that is 1, and that is one direction. The second direction is uh, you follow one definition, that is you need to assume that union A is disconnected, that is union A alpha is equal to union B, and then you want to find a disconnection, find a contradiction. Okay, so please think about, take your time, let me know. So, I mean, two way you can do it. Either show that take consider function union A infinity to plus minus one. That is one way. And secondly is that union of A alpha. Secondly is that you can consider the union A of the union B and solve using the first principles. Okay, so please try to do by yourself. Take your time. So the hint are as follows. So you can so so consider function f equal to 0 comma 1 and try to show that if it's continuous function. That means what, if you take any point x belongs to infinity, then every value will be some fixed point. Okay, so please try to do.
Hello.
Yeah, I'm audible.
Sir,
Yeah,
that's what I told.
yeah. So the problem is that so is it echoing? Hold on.
Can we approach the by that point of?
No, no, I mean, in between, I didn't hear you. So please repeat the argument.
Oh, the my voice is not coming or something.
Now it is coming. If you
Oh,
told the
okay.
argument before, then it was not coming to me actually. Possibly it
Oh,
was on mute. So please repeat the argument
I
again.
don't. Okay, I told like we can assume that it is not connected, and firstly consider like union of A alpha is a set, say A equal to union of A alpha, and assume it's not connected. So we can write this set as a union of two disjoint non-empty open sets. Let's say A equal to U union V. Now let's take a point x belongs to A. So there exists some index alpha such that x belongs to A alpha, because
Correct.
it does can't belongs to each A alpha because it's union. So after that, because each A alpha is a connected, so there exists some neighborhood around that. Basically, if we write these arguments, so we will get contradiction, like it will like prove that A alpha are disconnected, but we have given that A alphas are connected, so it will again contradict. So that means union of A alpha is connected.
Correct, correct. So that is one way, but that is a long way also.
Okay.
So the shorter way is to show the function method. That is, f is a map from union A infinity to 0, 1. You need to show that is a constant. Okay. So for that, what we
Okay.
do, since the given hypothesis states that intersection not empty,
Yeah.
so we can take intersection. I mean, P. We can take a point P from the intersection and consider the value f of P. Now, if we take a point x from union of A alpha, then anyway that point x belongs to any A alpha for some alpha, right? So that means f of, I mean, that means x and the point P belongs to the A alpha. That means what? F of x equal f of P, because each A alpha is connected. So that's why f of x equal to f of P for any x. That means what? F is a constant function. And that's what we need to show. So that's the full argument here given. So please go through the argument once and let me know. Then we shall go to the next problem. What drives you to go to the direction of pure mathematics? I mean, why not applied mathematics? I think, okay. Please go through the argument once and let me know. this argument is clear. So let's go to the next problem. So here we need to show that Rn minus single point is connected for if we're going to 2. And also, of course, you have to explain that why R1 minus 0 is not connected. Okay. So please try to do it by yourself. So please try to show that why Rm 0 is connected. So any idea? Or let me share the hint. So basically the point is that Rn minus 0 is path connected. That is what is connected. So the argument is given here. So okay, go through the hint and let me know the full argument. Okay, so the argument, so the hint is given, so there is nothing more to explain hint. So let me give you the argument. Wait a moment. Okay, so for n greater than equal to 2, so we are considering the LX straight line passing through a original X. Okay. Now, of course, the point line LX has minus 0 has two components. And consider the set AX, which contains all the line segments between X and E1. E1 means 1, comma 0, comma 0, comma 0. Okay. It's a line segment E2X. Now, if the point 0 belongs to AX, then A is connected, subset of Rn, containing both E and X1 because continuous image. If 0 belongs to X, then X equal to S of U1 for some S. So in that case, we can use S2 is equal to 0, 1, 1, the immediate next point to the next axis. In that case, the segment E2 to X avoids X0. This is where the segment E1 and E0 avoids both. In that case, AX is nothing but the line segment E1, E2, union the line segment E2, comma X. And that is also connected. So in both cases, X and E1 lie in the connected subset of R0. So that is why Rn minus point is connected. Okay. So that is the argument. Please go through the argument once again and let me know if you have any doubt or any question.
Is it ending the class meeting?
At 8.
At 8. Oh, okay. Sir, actually, I have more doubts regarding this. So, can I talk to you, sir?
Yes, yes,
Ah,
yes.
yes, yes, yes. Sir,
Okay, so go
sir,
through.
can I talk to you later after the class?
That's what I've said
That's what
already,
I've
right?
said already. Okay, okay, sir.
In that question 7. So okay, so please go through the argument question 7 and let me know is it clear to everybody or not. Or if yes, then we may go to the next problem. Okay. Okay, so let's go to the next problem. The next problem is the following. So in this problem, the first problem tells us every second count will be separable. That means what? Every second count is a countable, well, not countable, separable, countable tensor. So please try to prove it by yourself. This will be very easy actually. Please take your time. And also there is something a surgeon line and you should several doctor accountable. Please take your time. Let me know. Okay, so let me produce the hint. Where is that? So the hint are as follows. Please try to use those hints and solve it by yourself. Okay, so what's the time? Okay, so the hints are given. Please go through, share the hint, and also for the timing, I'm presenting the argument here. So the counter base is B, and from each of these basis set, we can pick a set density, and that density is tens. The argument is given. Okay, please go through the argument by yourself, and please try to understand. Okay, so please go through the argument. So there is nothing much to explain this argument itself. Okay, so I have this particular argument clear to everybody. So today is 8. So let's end here. So we shall meet on the next Sunday. Okay. Thank you. So one of the students doubt. You can start ask now.